So the focus of this lesson is looking at rational numbers expressed as decimals. And even though if you look at the start, I see some fractions, I want to decimalize these. And as I mentioned last day, any rational number can be written as a decimal, as an exact decimal. The decimal may repeat, but if it repeats, it has some sort of pattern. So if I want to write any of these as a fraction, for example, 2 1/4, you may just know that 2 1/4 is the same as 2.25. And these are exactly equivalent. And I know that quite quickly because 1/4 I know is the same as 0.25. Which again, if you think about a coin, a quarter, it's called that for a reason, and it's 25 cents. That's at -5/8 as a decimal. I know it's a negative number, but what's 5/8 as a decimal? Well, as we kind of mentioned last time, if you're ever not sure, just 5/8 means 5 divided by 8. So go 5 divided by 8 on a calculator, and you get 0.625. So again, -0.625 and -5/8 are exactly equivalent. 2/3, again, you may be aware of what this is already, but I go 2 divided by 3 on my calculator. My calculator says 0.666666667. Now that last 7 is only there because my screen ran out of space. It actually goes on forever, and my calculator just rounded it up to a 7, as most calculators will. And so if I actually write down 0.666666667, it's not exactly a 0.6 with a bar over it. And some calculators actually show that as well, that bar over it. And lastly, 3 8/9. I know this is the same as 3 point something. The question is, what's 8/9 as a decimal? Well, again, go to a calculator, 8 divided by 9. My calculator says 0.888888888 with a 9, but it's rounded because it's ran out of space, so it's actually 0.8 repeating forever. There we go. And like I said, if something is a rational number, you can write it exactly as a decimal. And vice versa. If you have a decimal, you can always write it as a fraction or a whole number. Always. Exactly. So all I want to do lastly, because a lot of these key ideas we already reviewed in some of the previous lessons. So I have 3 different expressions here, one involving addition, multiplication, and then division. All I want to do is, without a calculator, just determine will this expression overall be a negative or positive value. And so if I look at -1.08 plus 1.8, the key here is I have a negative number, I'm adding a positive number, but the positive number 1.8 is more than 1.08. So I'm adding more than I started with. You know what I started with was in the negatives, so I know this is going to be positive. Although I will say, if this wasn't 1.8, if this was 1.08, then I'd have the exact same value, but one is negative, one's a positive. We call that a zero pair, and together they'd make exactly 0. 0 is not a negative or a positive number. 0 is 0. It's kind of special. It's probably the most important number, but in this case, again, 1.08 and 1.8 are not the same value, so -1.08 plus 1.8 is positive. Over here, I don't actually care about the 2.7 and the 0.5. All that matters, if I'm trying to determine if it's positive or negative, is that I have a negative times a negative. And as we've reviewed before, negative times a negative is always a positive. No exceptions. And with dividing, again, I don't actually care about the 0.75 and the 0.5. All I care is I have a negative and a positive here. And a negative divided by positive is always negative. So notice my division and multiplication questions. If I'm just trying to determine if something is negative or positive, they are generally easier. There's a simple just pattern or rule you can remember. A negative and a negative make a positive. Same for multiplication and division. With subtraction or addition, there is no simple thing like that. You have to think about how they compare to one another.